So instead of taking ARMA 1-1, I will now go to ARMA 2-2. Okay. This is the simple to general methodology. The general to simple is quite opposite of this. It says that start with a plausible largest leg and then remove the insignificant. What is general to simple? It says that start with largest plausible ARMA order and then simplify by reducing the insignificant terms. Suppose I assume that largest plausible model is ARMA 3-3. How this is plausible? Because if I take ARMA 3-3, I have to include 3 legs of AR term, 3 legs of MA term. If I increase from this, there is the degree of freedom will become very small and there will be a problem. All right. So I have started from this point. Now what I will do, I will see on the significance of the coefficients that I have seen and will decide whatever is insignificant, I will drop it. And ultimately, I will have only significant legs in my model, and that is the end of process.
So I have a question. This term largest possible ARMA order, deciding ARMA order is a matter of relative judgment. To me, but I'm not sure how to decide what should be the most appropriate highest order, because deciding the most appropriate highest order, maybe she would be thinking some other highest order, I would be thinking some other highest order. So is there any benchmark to follow?
As I have said you, at every point you will encounter with some kind of subjectivity, and this is also one of those points. There are some rules of thumb, for example, square root rule. If you have 100 observations, what is square root of 100? 10. So you can have 5 AR legs and 5 MA legs and then start reduction. But what was the reason to choose this square root rule? There is no clarity. There are some rules of thumb, but they are also subjective, and how you can decide the largest plausible ARMA model, this is not clear by any way. But one thing which is clear, that is you cannot exceed the degree of freedoms. For example, you have 30 points of data. So if you choose 30 AR legs and 30 ML legs, you cannot do the analysis. Right? The degree of freedom must be somewhat smaller than your sample size. So, but how much it would be smaller, this is again subjectivity.
So another question. Yt minus 1 turns out to be insignificant, but Yt minus 2 turns out to be significant. Then what should we do? Because it's not necessary, आप जिस कह रहे हैं general to specific में we will keep on dropping the insignificant terms. So what if the t minus 1 term is insignificant but t minus 2 is significant? Does it make any logic? Number one. Secondly, what is the solution? How to, in this scenario, how to follow the general to specific?
Sometimes it makes very strong logic. Suppose you have quarterly data, so it's quite plausible that you have insignificant leg 2 and 3, but significant leg 4. Right? That will give you the annual pattern, quarterly pattern. Sometimes you have annual data, but you can see this kind of problems. Now, there are, if leg 2 is significant and leg 1 is insignificant, you have to keep leg 2. That is confirmed. That is what you have to do. But what about leg 1? Should it be kept in the model, or should it be dropped because this is insignificant? Again, there will become subjectivity. If you believe that the effect of leg 2 cannot be seen without effect of leg 1, you have to keep both of the legs. But sometimes you can drop the smaller leg to keep the larger leg if you see that the larger leg is having more importance. For example, there was some event which will take effect after 2 years. A new syllabus is introduced and the new syllabus will come into force after 2 years. And if you have things like this, then you can discard the leg number 1 and you can keep the leg number 2. But
Intuitively, there is no harm in dropping the prior leg.
yes,
If Yt is insignificant but t minus 2 is significant, there is no harm if we drop it, if the theory allows to drop it, or if intuitively the
if there is no strong theoretical sense that keeping leg 1 is very important, you can drop it.
We must differentiate on the basis of practical logic or statistical logic.
Basically, there was, you might have listened to the story that in 60s, the econometrics was doing very good. In 1960, there were a large number of econometric models and every model was performing very good and people were very happy. But in 70s, all of the econometric models failed to perform. And then people started investigating why this is happening. There were 3 different approaches. One approach was Lucas approach. He said that go into deep theory. If there is leg 1 which is insignificant and leg 2 which is significant, there might be theoretical reason behind this. Go into the details of this. And if you cannot find the details, just ignore the statistics, go on to the theory. Lucas is proponent of theory instead of data. There was another approach which is propagated by Sims. Sims says that there is no need of theory. If you have data, just see the pattern, just estimate the VAR model, and without having the trouble of going into the theory, you can make very good predictions out of it. And there was a third approach which was followed by David F. Henry and his co-authors. The Henry approach says that look at the theory and the data simultaneously. And among the theories, the theory which is supported by the data should prevail. For example, if you are looking at the models for consumption, there are large number of models, there are large number of theoretical models. This means that there are large number of logical connections. How the consumption is determined, there are more than one ways to spell this out. But which one of all these should prevail, which one should be trusted? You can have a model which is encompassing the existing theories, and then you can simplify the model on the basis of data, and ultimately you can reach any one of those theories, and this theory will be more prevalent, and it should prevail. Right? So this is one of the things that we will learn in this course. Otherwise, I don't think this is taught anywhere in Pakistan. Ji. One was Lucas, the other was Sims, and the third is Henry.
But sir, Sims also developed a model which is known as structural war model, which is based on...
No, basically, the issue is where are you placing weight? Lucas